In this problem, a ladder is placed against a vertical wall and a horizontal floor. The point on the floor is A and the point which is touching the wall is B. The forces acting on the ladder are weight of the ladder, it is given as 250 Newton, and the other forces will be reaction at a point A, reaction at a point B, a frictional force which is acting at point A. As in this problem, it is given that the wall is smooth, so we need not consider friction at B. So these are the forces acting on the ladder, and the ladder is placed in such a way that the lower point A is at 2 meters away from the vertical wall or from point C. And the length of the ladder is given as 5 meters. Therefore, BC can be calculated as square root of 5 square minus 2 square. If we consider this as a right angle triangle with the hypotenuse as 5 meter and the adjacent side, if this is angle theta, adjacent side as 2 meter, or using Pythagoras theorem, we can say it is BC square plus AC square equal to AB square or 5 square. From that we will get BC equal to square root of 5 square minus 2 square equal to 4.58 meters. When you calculate this, you will get it as 4.58 meters. And mu at A or mu F equal to 0.25. It is also given. Now, we need to prove that or show that the ladder will be in equilibrium or the ladder is not slipping. For that, in two cases, the ladder will be in equilibrium. That is, the first case, the frictional force at point A, that is the limiting friction, that is F A is equal to mu F into Rf, where mu F is the coefficient of friction at the contact surface of the floor, and Rf is the normal reaction at point A, that is at the floor. In this case, as it is a limiting friction case, the ladder will not be moving. It will be in limiting equilibrium. Then, if the frictional force here is at this point A, here is no frictional force because it is a smooth wall. At the floor, if the frictional force, say F, is less than Fa, then also the ladder will not be moving. So we need to prove that F is less than Fa. F is less than Fa. Let us see how we can prove it. So let us draw the free body diagram of the ladder first. This is the ladder, and two 2.5 meters, 2.5 meters. This is the weight, 250 Newton acting vertically downwards. This is Rf. This is the limiting friction, mu F into Rf. This is the reaction from the wall, Rw. This length is 4.58. and this is 2. Now, first of all, let us find out RF. How we can find out RF? As the ladder is not moving in the vertical direction, we can apply the equilibrium equation sigma v equal to 0. That is, algebraic sum of vertical forces equal to acting on the ladder equal to 0. Sigma v equal to 0. That is, that will give RF is acting in the vertical direction. So it is taken as positive minus 250 in the vertically downward direction. So it is taken as minus RF minus 250 equal to 0. That will give you RF equal to 250 Newton. RF equal to 250 Newton. Then the limiting frictional force equation we know. Limiting frictional force FA is equal to mu F into RF. That is, mu F is 0.25 into RF is 250. That gives FA equal to 62.5 Newton. So this is the maximum value of friction that can be offered by the floor with the coefficient of friction of 0.25. Okay, now we need to show that the frictional force acting at this point is less than or equal to Fa. So instead of mu F into Rf, we will consider a force F instead of mu F into Rf, we will consider a frictional force of F at point A. So this is point B and this is point A. Okay, and this is point C. Okay, so to find out the frictional force F, we will use the equilibrium condition or equilibrium equation sigma mb equal to 0. That is, algebraic sum of all moments of all the forces or moments of all the forces about point B equal to 0. Okay, so what will be sigma mb equal to 0? The forces which are creating moment are Rf, the weight of the ladder, the force F, frictional force F. Rw will not be making any moment because it is acting through the point about which we are taking the moment. So Rf will be making an anti-clockwise moment like this, anti-clockwise moment. So minus Rf into the moment will be perpendicular distance will be, this is the point B about which we take moment, and this is the distance of line of action of the force Rf. So it is 2 AC, that is AC, that means 2. Then 250 Newton. Next one is the frictional force F, which is making a clockwise moment like this, plus F into perpendicular distance between the point and the line of action is 4.58. Then another force which is making moment is the weight of the ladder, which is creating a clockwise moment. So again, plus 250 into what will be the perpendicular distance between the force and the line of action and the point. It will be 1 meter. So it will be into 1 equal to 0. No other forces are there, or RW will not create any moment. At B there is no frictional force because the wall is smooth. Therefore these are the forces which create moment, and this is the value of net moment. So it will be RF, we have already got it as 250. So minus 500 plus 4.58 F plus 250 equal to 0. That gives 4.58 F is equal to 250, or F is equal to 54.59 Newton. F is 54.59 Newton. So FA, the maximum frictional force or limiting frictional force, FA is 62.5, and we got the frictional force as per the arrangement of the ladder is only 54.59 Newton. The floor can offer a maximum of 62.5, and now the frictional force which is acting on the ladder at present is only 54.59. That is, F is much less than FA. That means the ladder is in equilibrium, or the ladder will not be moving. The ladder will not be moving. Hence, the ladder will be in equilibrium.